Hello, my name is Keith Beattie, and I'm going to talk to you today about some experiences that Dan Gunter and I have had working at Lawrence Berkeley National Laboratory, building up some experiences for some useful practices that we've learned for software engineering on medium-sized distributed scientific projects. So to give you a little sense of what our context is and what our challenge is a lot of the projects that we have various scales. For example, we have contributors, a number of contributors. The particular project we're going to talk about today has about 30 to 40 contributors. They're not all software developers, but they all have input into the roadmap and the feature set for the software that we're developing. It spans multiple time zones. So in terms of geography, we've got people standing across the entire continental United States. Unlike other projects where you may only be on a single time zone, or you could be worldwide. This other section here, or scale of different software engineering experience of the different contributors on the project. On one side, you may have what I've kind of identified as a solo scientist. This would be somebody who comes from another scientific discipline that came to software development by virtue of working on their own data set that they collected, wrote some software to analyze that data set and produce some results from that. On the other scale, you have somebody who is primarily a software engineering background, who has worked on large software engineering efforts. For a lot of our projects, this one in particular, it tends more towards the solo scientist side than the fully experienced software engineer. There's also the number of different institutions that are involved in the collaboration. So we usually have, in this particular case, I think we've got about 5 different institutions that are involved. So it's not just a single institution, but it's there's multiple institutions involved. So that plays into an important dynamic about authority structures and how you can deal with those situations. So the particular project that I'm going to go into details on is something called IDEAS, which is the Institute for the Design of Advanced Energy Systems. And what we're doing for this is we're developing a software framework for modeling chemical processes with a focus on power plants. So the main funder behind this is the Department of Energy, Office of Fossil Energy. So we've got about 40, as I said before, 40 different contributors. They're almost all part-time, which is an important thing to point out. I'll get to later. 30 of them or so actually have a chemical or process engineering background. They do not have a software engineering background. There's a few of us who do have come more from a computational science, computer science, software engineering background. And then we have some others who are more chemists and straight up material scientists. As you can see from the map here, at LBL, that's where Dan and I sit. This is, as well as a few other contributors on this project. We have other collaborators at Sandia National Lab in New Mexico, University of Notre Dame, NETL, that's a DOE National Lab in Pittsburgh, along with CMU, Carnegie Mellon, and West Virginia University. So we span 4 time zones. So a lot of times, in terms of how to manage a software engineering project, Scrum has been a very popular methodology to run these projects. So to that end, we had a person come in at LBL and give a presentation to talk about Scrum. He went through the whole thing about stand-up meetings, 2-week sprints, different stakeholders and all that sort of stuff. At the end of the at the end of the talk, which I thought was actually quite interesting, somebody else beat me to the punch and asked a question, which was, how can we, in a research and scientific environment where our collaborators are spread across both multiple unrelated projects and time zones, how can we best apply the Scrum methodology? So the speaker took a long pause, and finally his answer was to find another job, which was pretty humorous. It was a little bit disappointing. I thought it was frankly honest, because I think what he really was saying is that Scrum does not necessarily apply in our particular context. So the question really then becomes, what does work? First thing is you need to point out that Scrum makes a few assumptions that don't apply in our particular environment. For example, it assumes that all of the participants are full-time, which is almost never the case for our scientific projects. It assumes that all the participants are in a single location, which is almost never the case for our projects. We usually have both those things at the same time. Perhaps Scrum could work if you have one or the other, but if you have both, it becomes a real challenge. There's also an assumption that there's a single authority. A lot of times when you have multi-institutional collaborations, there is no single authority like, VP of engineering or CTO or something like that to say, here's the methodology you're going to use, here's the tools that you're going to use, here's the roadmap that you're going to have. So what we need to do is figure out what parts of Scrum do still apply that we can apply to our software engineering effort. There's still quite a few if you step back from Scrum and look at the larger agile approach to things. So that's what we've done. So I'm going to try to walk you through a process that we have come about that so far seems to be pretty effective. The high points here are that we have regularly scheduled meetings. We have scheduled releases. We very much work at an iterative, moving towards incremental improvements at all scales. And then finally, there is an evangelism, educational, and what we might call soapboxing. So let's get into that. The first is scheduled meetings and scheduled releases. So what we do is we have weekly telecoms with the entire development team who is actively contributing code to the project. The daily stand-ups are going to be a little bit impractical because of the way that people are split across all the different projects. It could only be like 10 or 25% of their time is for this particular project. So we have weekly stand-ups. Usually people can, that's achievable. We have date-driven, not feature-driven releases. So the best way to capture, I think, the advantage of this is that you can tell everyone, if you miss the bus, there's going to be another one coming along soon. So if your feature or your bug fix, for whatever reason, is not finished, that's okay. The release will still go out, and you'll get on the next one. What this really ends up being is a very subtle but effective motivation to meet that date. After people realize it's a shuttle that goes out every, whatever your time slice is. People will realize that, they'll recognize that, and they'll start to schedule their own work accordingly and make your dates. These two things fill in or are manifested in what I kind of think of as Kanban-inspired project boards. These are the project boards that we use GitHub, and I find those project boards very, very handy. We create two of them. I have one which is a priority board. So every issue and a lot of PRs will go on the priority board in order for us to be able to look at what are the relative priorities of addressing that particular issue, whether it's a bug fix or a feature request. Then we'll have a release board. Now, this will be a release board that's specific to that date-driven release, and that'll have all the issues and PRs that are targeted for that release. And we will go through those release boards every week. That's what the weekly call primarily is about, is walking through all of those issues, asking about what's happening with them, if there's any blocks on them, discussions that have to happen. A lot of times we'll actually do quick reviews of a PR and even merge them, and review the test results and those sorts of things. So the results of combining all that together is that we have a development process that's open to everybody who's on a collaboration. I will invite managers to these things even if they're not actively involved in the development, so that they can be engaged with what's happening in the development. I'll try to use screen sharing a lot of sharing those project boards. We'll look at the continuous integration test results. We'll even review high-level project milestones to make sure that we're staying on track with our results. It's also an open forum for technical discussions. A lot of times you need to have face-to-face or as close as you can practically have discussions about things to settle open questions or decisions about technical decisions. We'll try to build into this some camaraderie about making relationships with people. And I always try to encourage people to have their video on. That's not always possible though. The next step is we want to iterate that step over and over and over again. And there's also the communication out. So let's take testing as an example. Everybody's favorite thing to do as a developer. I'll try to encourage people to start small, just have a very small test that maybe just like does a basic smoke test, import the module or something simple like that. And then we'll build incrementally with it over time. And eventually you can then add test coverage, you can add linting into it for style guide enforcement, and you end up with something that is like, that can eventually be very powerful as you do this incremental approach towards improving the efficacy of your testing continuous integration system. It's an educational process for people who aren't quite as familiar with it. Exactly, iteration, it's an educational process. It's also forgiving by the same bus analogy. If you miss this one, you can catch the next one. And that adds up to being something that is very forceful and powerful, we found. Another important aspect of all this is evangelization. Basically, making sure that everybody, not just the technical team, of course, understands what that process is, and then try to push that awareness of what the process is, what all these steps are, push that back up the management stack so that the project management will become aware of the process that you're executing, and eventually in our scientific and research environment, the funding sources, so that they're aware of the importance of a mature software development process in order to get scientific software that serves the goals of the funding agency. Finally, we want to sharpen the saw, which is basically improve the approach itself. And one of the ways that I'm trying to do that right now is by engaging with professional organizations such as Collegeville, other research, science, engineer organizations in order to get feedback. I would love to hear from people whether or not they think this is a good approach or if there's ways that it could be improved. I'm looking forward to listening to other people's talks about this as well. So in summary, we have some unique challenges in our scientific and research environment. It's distributed across geographic time zones. It's multidisciplinary. We do not just have software engineers. We have scientists of all different disciplines. We're almost always time sliced. We can never give 100%. Sometimes we can never even give 50% of our time to a particular project. Talking about the IDEAS project as an example, we've learned Scrum is not really always going to be the answer, but we can come up with something that can work, we found. So scheduled meetings, scheduled releases, this iterative, powerful educational improvement, and then proselytizing back up the management stack so that people are aware of that. There's always going to be technical challenges that remain that really can't be avoided, but there's also some challenges that are not technical, and those are mostly social things and social challenges and communication challenges. So the idea is that we can have a process where those social and communication challenges can be addressed so that we can then conquer the technical challenges that need to be dealt with. Okay, so here, sorry for the jump in theme, but here is our acknowledgement slide, all the different contributors and institutions that are involved in this. And thank you very much.